Hello, students. Welcome to another hybrid lecture of cryptography and network security course. Hope you have a clear idea about the cryptography definition, how the definition justify the cryptography technique, that is the encryption and decryption, what we have discussed in our last class. As we know, that cryptography is a technique to hide the data somewhere inside the message that to be sent. So in this regard, today we'll discuss about the substitution cipher. So just a brush up to the previous class, we need to know that what is actually a cryptography is. So just a brush up, move to the definition part. So cryptography is a word. The term itself defines a hiding of data within a picture. If we break the word cryptography, graph means a picture and crypt means to hide. So in a picture, if we hide some data and the picture to be sent to the receiver from the sender, so receiver can get the data in the form of a picture and the data can be hid behind that picture. By implementing this particular idea, by implementing this particular technology, by implementing this particular secure communications, we can able to define the term cryptography. As we have already discussed, cryptography is nothing but the inclusion of two processes. The two processes is nothing but the encryption and decryption. And where it is going to be implemented during the communication and to make that communication more secure. Moving to the next, when the sending data convert into a unreadable form, that becomes the process of encryption and that called ciphertext. Yes, you're right. Ciphertext. It is called cipher, and the data that what to be sent or that mean to be sent, that is called plain text. That means the data that what we can able to read, that is called plain text, and the data that we actually send, that is jumbled up with some keys, that is known as ciphertext. Coming to the next process, decryption. Decryption is nothing but the reverse process of encryption with the same algorithm, with the same key, but in opposite process or reverse process. That's why it is known as the process of converting ciphertext into plain text. So this is the brush up to the previous classes. I think till this everybody has clear idea what is encryption, what is decryption, how the both process combine into make this a crypto process or cryptography process. Moving to the next. Today I will discuss about substitution cipher. Yes, you heard the right. Substitution cipher. It is nothing but the alphabetic cipher that what we need to study. So let's have an example of normal encryption and decryption. Then we are moving towards substitution cipher. So here my message is the location is moon. So the message is the location is moon. So this message need to be sent to the receiver end, but not in this form, but in a encrypted form. So this encryption can be done with a particular technology that is known as substitution cipher, but here it is called as Caesar cipher. Caesar cipher. T. T is the alphabet that convert to W. After T, if we count U, V, then W. So the positioning of the alphabet plus 3. The positioning of the alphabet H, I, J, I, J, K. So plus 3 in every letter position or alphabet position we add plus 3, so that position number plus 3 is the next position number of the alphabet. Clear? And this particular technique is known as Caesar cipher. What we have done here, we just create a cipher text by adding the positioning number plus 3. We just add plus 3 in the positioning letter in the English alphabet, and we just substitute the alphabet with another letter. That's why it is called as substitution cipher. I think everybody has clear idea how it's taking out. So here is your task. Write down the message, the location is moon, and do this plus 3 and find out this will be your ciphertext. Quick. Side by side along with you, I am doing the same. So T plus 3. So U V W H I J K E F G H L M N O O P Q R C D E F A B C D. Again T is W I J K L O P Q R O O P Q R. This should be R. I O O P Q. Okay, I. This should be R. Then this should be R. This should be R. Then L. I is L, yes. S T U B, T U B, okay. M N O P, O P Q R, O P Q R, then N O P O P Q. Yes. So this should be R. There is a mistake. So here you understand how the substitution cipher work. Coming to the advantages of this substitution cipher, the attacker might be confused. The attacker might be confused how the message could be decrypted. Okay, but there is a disadvantage, or that is a advantage for attacker. Disadvantage of this algorithm, and there is a advantage of attacker. What is the C? Here O is always R. Here O is always R if we are doing the substitution cipher using scissor cipher, and the key should be +3. Okay, so make it more complex type of cipher text. We need some complex type of substitution cipher. So this is very simple to understand. There are many complex type of substitution cipher. We need to discuss one of them in today's class. So before going to that particular algorithm, that is known as Playfair cipher, we need to understand, or we need to define what is a substitution cipher. So as the name contains substitution, so it must substitute the letters, bits, binary digits, etc. It is mono-alphabetic, as it just substitute a single alphabet at a time. Okay, so let's have a look to the definition part. In cryptography, a substitution cipher is a method of encrypting in which units of plain text. Here it is written units of plain text. It is not written that a letter or a character of plain text. Why? Because just to understand, we saw how scissor cipher substitute the text, plain text into cipher text. But inside a digital media, inside a communication medium, inside a computer world, the data should not be on alphabets. The data must be on 0, 1 bit or some other forms. That is unit. So unit of plain text are replaced with the cipher text in a defined manner. So the examples that we have already done, what is the defined manner in that example? In that example, the defined manner is +3. We have defined our process of +3 to be counted on the position of the alphabet. Yes, moving to the next line. With the help of a key, with the help of a key, that means there in the examples that we have already done, in that example, the key is +3. The units may be single letters, the most common, pairs of letters, triples of letters, mixture of above, and so forth. So in our previous slide, if we see that we just replace a single letter, so it is monoalphabetic. But if we replace two alphabets at a time, that is not monoalphabetic. That is a pair of letters, that is triplets of letters, mixtures of above. That may be. So moving to the actual discussions of the today's class. Let's have a look to the substitution cipher, how it works. So this is another example of substitution cipher, roti 13. So if we do positioning of different numbers, A becomes N, B becomes O, C becomes P, D becomes Q. So it is just division of 26 letter, 13 is 13 next. So how hello can be encrypted? H becomes U, E becomes R, L becomes Y, and O becomes B. So hello becomes RAB. What is it? Hello becomes RAB. Okay. Next. So come to the Playfair cipher. That is, it is the cipher in which we can do the substitutions of letter, but two at a time. Yes, but two at a time. Let's move to the history of the Playfair cipher. It is the first practical digraph substitution cipher. Playfair cipher is the first practical digraph substitution cipher. The scheme was invented in 1854 by Charles Wheatstone, but was named after Lord Playfair, who promoted the use of cipher. That means Charles Wheatstone just created the logic part, but Lord Playfair has promoted this cipher, so according to his name, its names because Playfair cipher. So in Playfair cipher, we just encrypt a pair of alphabets. That's why it is called digraphs. Di means two, graphs means letters or pictures. But we are not taking pictures here, we are taking letters here. Okay? So in Playfair cipher, we encrypt a pair of alphabets instead of a single alphabet. So in our last examples, in scissor cipher examples, we have seen a single alphabet can be replaced by a single alphabet. But in this Playfair cipher, we will do that a pair of alphabet can replace a pair of alphabet. For this, we need a message that to be sent to the receiver by the sender. If we go through the book, you can find that Alice and Bob. In book, you can find there is only one sender Alice and there is only one receiver Bob. Okay, so moving to the next example. The Playfair cipher is a manual encryption technique that uses a digraph substitution cipher to encrypt plain text to ciphertext. Yes, you can do automatic. You can make it automatic by writing a program, but it's charm when we are doing it manually. There is a charm. There is the tricks that we are able to know. The Playfair cipher is a manual encryption technique. So moving to the example, finally, we are going to do the Playfair cipher with the message. The message is here our plain text is instrument. We just want to send a single word instruments to the receiver, to the node, and here our key is monarchy. Sorry. So here our key is monarchy. So let me highlight. This is the plain text. This is the keyword. So we need to jumble the plain text with the keywords. Now we see how we can able to do it. So in English alphabet there are 26 letters. If we arrange the alphabet in a 5 cross 5 matrix, that is 5 rows and 5 columns, then we can able to arrange the 26 alphabet in a 5 cross 5 matrix as 25 alphabets. So we need to adjust two alphabet in a single location. Okay, so let's create the matrix first with the help of keywords. So here monarchy, monarchy is the key. So let's arrange monarchy, monarchy. So in a 5 cross 5, 25 places, let's arrange or let's place the keyword one by one, letter by letter from the starting cells. So M is here, O is here, N is here, A is here, R is here, CHY. So we have already placed 1, 2, 3, 4, 5, 6, 7, 8. 8 letters. Okay. Rest letters or rest alphabet of the English alphabets, we have to arrange them in the rest cell without repeating the alphabet one more time. Okay, so let's arrange all the rest of the letters. So monarchy we have written here. Next B, already C is here. Next D, E, F, G, H is here. I and J we need to place it in a single place as per the Lord Playfair. Then K, L, O is K, I, J, K, L, M is here, N is here, O is here, P, Q, R is here, S, T, U, V, W, X, Y is here, and now Z. So understand? First, we need to create this particular matrix. Clear? After creation of this matrix, we need to create the pairing of letters from the plain text. So this is our plain text. What we will need, we need to make it a pair in like this. IN is one pair, ST is another, RU is another, ME is another, NT is another. Okay, then S each left. If we see 1, 2, 3, 4, 5, S each single. So to make it a pair, we just need a arbitrary letter. We can add a X or a Z, anything. That depends upon the user who creating the ciphertext. Moving to the next, how it is going to work. So this is our arrangement of alphabets in a 5 cross 5 matrix. So first pair is IN. So three formula is there to know how to pick the ciphertext. If the letters are in a single row, let's say this IN in a single row, then we need to select the right side letter of the subsequent plain text. So if this should be there, then it will rotate and this should be selected. Suppose it R is there, then we should select M. Let's see. We'll do and you will understand. So first one is IN. So here the green is our uh, plain text and the red one is our cipher text. So IN, I and N. So conjunction. This is G, and if we go I to N, this side we got G. If we go I to N, this side we got A. Okay. So our first cipher is DA. Next we got ST. So ST. These are in single row. So S. So we are getting the right side T. For S we are getting T, and for T we are getting L. Okay. So we are getting T and L. And for R and U. So conjunction we are getting M and Z. So we are getting MZ. Likewise, for ME, M and E both are in the single column. When it is in single column, we need to take the next letter down the letters. Okay? If it is in a row, we need to take the right side of that letter. If it is in a column, we need to take the downwards of the letter. So M, the down letter is C, and now it is E, the down letter is L. So we need to take CL. Okay? Now next is NT. N is here, T is here. So conjunction is Q and conjunction is R. So we can take RQ. Now SZ. S is here, Z is here. Both are nearby diagonally. So we are getting the conjunction TX. So let's have a review. We just get the plain text instruments and we get the keyword monarchy. So we get the pairing of the letters as IN, ST, RU, ME, NT, and S is single. So we just append it with Z. So we are getting SZ. So if for EIN, I is here, N is here. So we are getting the conjunction letter GA. For ST, it is in single row. So for S, we are taking T, and for T, we are taking L, just making a round. For RU, we are taking conjunction letters MZ, and for ME, we are taking, as it is in a single column, we are taking the next letter down that letter, so CL. Okay, and for NT, we are taking QR, and for SZ, we are taking XT. So our final cipher text is DATLMZCLRQTX. So here you see the plain text is instruments. It has a meaningful word, but here we are getting Gattelmakelokrashtx. You can't pronounce it. It doesn't have any sense. So this is known as ciphertext. And this is what we have done today. This is the substitution cipher, and the technique is called Playfair cipher. Okay, so I request all the students to do this Playfair cipher by themselves, by mm, getting the matrix, and do it by yourself so that you can understand very clearly. And try this example. Monarchy is the key and instruments is the uh, message or plain text that to be sent. Try this and you can get this type of plain text. And with the monarchy keyword, try the another key pair. I am giving you the Another plain text. The plain text is the world. The world is nice. This is your plain text, and you need to implement the Playfair cipher, and the keyword is as it is monarchy. So you need to arrange all the alphabet in a 5 cross 5 matrix. But before arranging, you first arrange the keyword monarchy, then arrange the word is nice without repeating any letter. If you repeat the letter, you can't accommodate all the letter, or you can't arrange all the letter inside that matrix. And that should be the arrangement of key with the plain text, and you will get the cipher text. Okay, so with this today's class we sign off. If you have any doubts, do let me know. You have my number. We have our official group. You can contact me. So from next class onwards, we'll discuss another topic, that is services mechanisms, or we can go for the extra algorithms for the cryptography. Signing off. Thank you, students. Do let me know if you have any doubts. Thank you.